In this first part of a series of videos, we're going to examine how we can use Microsoft Excel to perform a one-factor analysis of variance to examine differences if statistical differences exist in between different groups. And in this scenario, here we have 5 fictional groups, each containing 7 unique research participants, and we have a set of scores that were obtained from each of the participants in each of the 5 groups. What you see over here on the right hand side are the core equations used in performing the one factor analysis of variance. And what we're going to do here is we're going to first perform our descriptive statistics calculations, and that's the standard step where we want to describe the data for each group separately, and I have that in the blue here. So the first step is to calculate the sample size, or rather ask Microsoft Excel to calculate the sample size, and I'm going to put that value in the cell just beneath each group. So I'm going to hit the equal sign. I'm going to type in the Excel command count, shift 9, and I'm going to grab the array of cells in order to calculate the sample size. I'm going to shift 0, hit enter, and we see that we have a sample size of 7 in the first group. I want to do the same with each of the other 4 groups, so I'm going to highlight this cell. I'm going to move my cursor over to the bottom right hand corner where it changes image to a plus sign. I'm going to hold the mouse key, the left mouse button down, and drag it over, and we see we have a sample size of 7 in each of the 5 groups. The next step is to calculate the average score for each group separately, and I'm going to hit the equal sign, and I'm going to type in the Excel command average, shift 9, and I'm going to grab the array of cells, highlight the array of cells over which I want to calculate the average. It's important to pay attention that you don't drag over into the previous cell where we calculated the sample size. I'm going to shift 0, hit enter, and we have our average value for the first group. I'm going to highlight the same cell where I calculated that average, and I'm going to move my cursor to the bottom right hand corner. I'm going to pull it across, and we have the average for each of the 5 groups. The third descriptive statistic is the standard deviation. I'm going to put that in this cell right below the average, and I'm going to hit the equal sign. I'm going to type in the Excel command for this, stdev dot s, because I want to return the standard deviation on a sample. I'm going to shift 9, and once again I'm going to grab the array of cells over which I want the standard deviation computed. Shift 0, hit enter, and we have our standard deviation of the around the average for our first group. I'm going to highlight this cell, grab the bottom right hand corner, and we have the standard deviations associated with each group. What we see here in the column next to group 5, column G, is what we call grand, and what we need to calculate here for the ANOVA is a grand or overall sample size, and I'm going to put that right here in this cell. And to do this, I just need to add up all of the individual sample sizes for each group. So I'm going to hit the equal sign, type the command SUM for sum. I'm going to shift 9, I'm going to grab the array of cells, close it, shift 0, and hit enter. What we have here that we will need for the ANOVA calculation is the grand mean, or the overall mean of all of the participants collapsed across all 5 groups. And there are 2 ways to do this. The first way is I'm going to hit the equal sign. I'm going to type in average, open parenthesis, but I'm going to calculate the average of the averages for all 5 groups that I had completed in the previous step. However, note that to do this, we are assuming that the sample sizes are the same in each of the 5 groups. If the sample sizes are different, we would have to compute a weighted average. But that's not a concern here, so I can go ahead and highlight the 5 averages, shift 0, hit enter, And I have an overall average of 5.77. I'm going to delete this value right here, and I'm going to redo the average calculation. Once again, I hit the equal sign, I type in the Excel command, average, Shift 9, but this time I'm going to highlight all of the raw data into this calculation. I'm going to Shift 0, and once again here you see the same value of 5.77 that we had computed from the previous way to calculate the average. However, it's important to note that those two average values are equal because of the same sample sizes. So the best way to do this when using Microsoft Excel, instead of calculating the average of the averages, is to calculate an overall average of all of the cells. Okay, the next step is to calculate an overall standard deviation around the overall average, and we cannot average all 5 separate standard deviations. So I'm going to hit the equal sign, stdev for the Excel command, .s for our sample. I'm going to Shift 9, and I'm going to highlight the array of cells over which I want to calculate the standard deviation. I Shift 0 and I hit enter, and so overall we have a standard deviation of 1.70 rounded around the overall average of 5.77. However, we will not be using this standard deviation in the ANOVA approach, but we will need the grand mean and we will need the grand sample size. So in the next video, we're going to take the first step into the ANOVA calculation by focusing on what we have here as the sum of squares between and its associated degree of freedom, and we're going to put those calculations underneath the descriptive statistics that we had just calculated, and we'll pick up that on the next video.